In section 5.7, we're looking at synthetic division and the remainder theorem. Our learning objectives are to use synthetic division to divide a polynomial by a binomial. This is a shortcut for long division. The second objective is to use the remainder theorem to evaluate polynomials. Use synthetic division to divide. We have the quantity x squared plus 2x minus 8 divided by the quantity x minus 2. Now the synthetic division shortcut only works when you're dividing a polynomial, when you have some polynomial, we'll call it p of x, divided by a binomial in the form of x minus c. So the synthetic division only works in this case. As you can see, we're dividing by x minus 2, so this is a good example for using synthetic division. In the setup for synthetic division, we begin with a little box in the corner here. That is the value of our c. So when we do that setup, we're going to put the c in the box, and then we're going to put the coefficients here. And then we're going to bring down the first coefficient. Whatever's under the line, you're going to multiply by what's in the box, and that number goes in the second location. You always add going vertically, and whatever's below the line, you're going to multiply by what's in the box. It'll make more sense after you see a few examples. Since we're dividing by x minus 2, we're going to put a positive 2 in the box. And we're looking at just the coefficients of the original polynomial. Here we have 1x squared with a coefficient of 1, plus 2x, the coefficient is 2, and the last constant term is negative 8. I'm going to leave a space, and this is our setup for this type of synthetic division problem. The very first coefficient you're going to bring down below the line. Anything below the line, you're going to multiply by the number that's in the box. So 1 times 2 is 2, and that number goes above the line in the next column. Now the two numbers that are above the line, you're going to add together. So 2 plus 2 is 4. And then whatever's below the line, you're going to multiply by what's in the box. 4 times 2 is 8. Now the numbers that are above the line, we add those together to get negative 8 plus 8 is 0. Now this last number is your remainder. If you were doing this problem using long division, your remainder would be 0. So that means x minus 2 divides evenly without any remainder. And since we started off with an x squared in our original polynomial, when we divide out an x, we end up with one lower power. So the answer is 1x to the first power plus 4 with a remainder of 0. And we can write this answer as x plus 4. So the polynomial x squared plus 2x minus 8 divided by x minus 2 is x plus 4. Now let's look at the example x squared plus 2x plus 4 divided by x plus 3. So when we set up this synthetic division, we're using the coefficients of the original polynomial. X squared has a coefficient of 1, 2x, the coefficient is 2, and plus 4 is the constant. Now the number that goes in the box corresponds with dividing by a factor x minus c. Now we're dividing by x plus 3. There's no minus sign, but we can think of this as x minus a negative 3. In fact, the number that goes in the box is the number that would make that factor equal to 0. If x is equal to negative 3 plus 3 is 0. So if you're dividing by x minus 2, as in the first example, we put a positive 2 in the box. In the second example, we're dividing by x plus 3, we put a negative 3 in the box. Let's work on the first. After you get the setup, you always bring down the first coefficient of 1. Anything below the line, you're going to multiply by what's in the box. So 1 times negative 3 is negative 3, and that number goes in the next column. We're going to add those together. 2 plus negative 3 is negative 1. Now the number negative 1 below the line, we multiply by the negative 3 in the box to get positive 3. And then you're going to add those together, 4 plus 3 to get 7. So in this problem, when you divide, if you were doing this using long division, you would have a remainder of 7. So our answer is found by using the numbers that appear below the line. Since we started off with an x to the second power, the first number 1 is the coefficient of x to the 1 power, or first power. We always reduce that power by 1. Minus 1, which would be your constant, and then the remainder 7, we write as a fraction 7 divided by what we were originally dividing the entire polynomial by, x plus 3. So we can write our final answer in simplified form as x minus 1 plus 7 over x plus 3. In example C, we have the quantity x squared minus 8x plus 15 divided by the quantity x minus 5. So this is a good one for using synthetic division since we're dividing by an x minus c. In this case, we're going to put a positive 5 in the box. It's the value of x that would make that divisor equal to 0. So if we put a 5 in the box, then we use the coefficients. The coefficient of the x squared is 1, coefficient of the x is negative 8, and the constant is 15. Now the first number we're going to bring straight down. The first coefficient of 1, whatever's below the line, you're going to multiply by the number that's in the box. 1 times 5 is 5. Then we're going to add those together. Negative 8 plus 5 is a negative 3. Now the number negative 3 below the line, we multiply by what's in the box to get negative 15. And when we add the numbers above the line, we get a remainder of 0. So we can write this as 1 is the coefficient of the variable, the first variable. Since we start off with an x squared and we divided out an x, we reduce that power by 1, so it's 1x to the first minus 3 with a remainder of 0, or we could just write it as x minus 3 as our final answer. For example D, we're taking the polynomial 5x squared minus 4x minus 9 and dividing by x minus 2. Since we're dividing by an x minus c, or x minus 2, the number that goes in the box is a positive 2. The coefficients are 5, negative 4, and negative 9. We bring down the first coefficient of 5. Whatever's below the line, we're going to multiply by what's in the box. 5 times 2 is 10. We add the numbers that are above the line. Negative 4 plus 10 is 6. And then 6 times 2 is 12. And then we add the numbers above the line. Negative 9 plus 12 is 3. So we have a remainder of 3. The first number below the line is the first coefficient, 5. And since our original polynomial was an x squared, we reduce that power by 1 plus 6 plus our remainder 3 divided by the x minus 2. So our final answer, 5x plus 6 plus 3 divided by x minus 2. For example E, the polynomial 9x to the third plus 9x squared minus x plus 2 is divided by the binomial x plus 2/3. We can use synthetic division for this type of problem since it is in the form of dividing by x minus c. We have x plus 2/3. What we want to do is write it as x minus a negative 2/3. So in the setup for synthetic division, we're going to put a negative 2/3 in the box. Then we write the coefficients, 9, 9, negative 1, and 2. We get those coefficients from the original polynomial. We leave a space and draw a line. We always bring down that first coefficient of 9, and whatever is below the line you're going to multiply by the number that's in the box. So 9 times negative 2/3. 9 times negative 2/3 is negative 18 over 3, or negative 6. We're going to put that negative 6 above the line. We're going to add going straight down. 9 plus a negative 6 is a positive 3. Now the number 3 we're going to multiply by the number that's in the box of negative 2/3, and negative 3 times negative 2/3, positive 3 times negative 2/3 is negative 6 over 3, or negative 2. we're going to put that negative 2 above the line. We add going straight down. Negative 1 plus a negative 2 is a negative 3. Now we're going to take the negative 3 and multiply by the number that's in the box, negative 2/3, which we get 6 over 3. And 6 divided by 3 is 2. So that number 2 goes above the line. And then we're going to add the columns together. 2 plus 2 gives us 4. And that last number is always the remainder. Our answer now, we use the 9, 3, and negative 3 as coefficients. The numbers below the line we're going to use as coefficients. So I'm going to use 9 as the first coefficient of my answer. Since the original problem was an x to the third power, the answer is reducing that power by 1. Since we're dividing, we get 9x squared plus 3x to the first minus 3 plus our remainder 4 divided by x plus 2/3. So we're using the coefficients, the numbers below the line as our coefficients. We have 9, we have 3, we have negative 3, and then our remainder is 4. So our answer is 9x squared plus 3x minus 3 plus 4 divided by x plus 2/3. For example F, we have the polynomial 4x to the third plus 5x divided by 2x minus 1. Now in order to use synthetic division, you are dividing by an x minus c. However, here we have 2x minus 1. So the 2 in front is going to cause us some problems, but there's a way around this. We can take this, what we're dividing by, which is 2x minus 1. We're taking the 2x minus 1 and dividing it so that the x that you're dividing by has a coefficient of 1. If we divide that by 2, this is the same thing as 2x divided by 2 is x, and negative 1 divided by 2 is negative 1/2. So notice here that we divided that factor by 2, and we're going to have to make an adjustment later on. So we can set this up with synthetic division with a 1/2 in the box, and then the coefficients of the x cubed term, 4. It's missing an x squared term, so I need to include a 0, and then the x term has a coefficient of 5, and the constant there, you don't see it, but our constant is 0. So the setup here, we need to make some adjustments into 4x cubed plus 5x is missing an x squared term, so we consider that as 0x squared plus 5x plus 0. So we want to make sure we use all those coefficients. And we're going to bring down the first coefficient of 4, multiply by the number that's in the box. 4 times 1/2 is 2. We're going to add those together. 0 plus 2 is 2. Now 2 times 1/2 here is 1. We're going to add those together. 5 plus 1 is 6. And then 6 times 1/2 is 3. And then 0 plus 3 is 3. Now we're going to use these coefficients, but we need to make the adjustment about this dividing by 2. We're going to need to take and divide that quantity by 2 as well. Since we've only divided by the x minus 1/2 in this synthetic division, we haven't divided by the 2, the multiple of that. So we want to divide this by 2 so that our coefficients will be 2, 1, and 3, with that remainder of 3 as well. So our answer we could write as 2x to the second power. Since our original polynomial was an x to the third power, we reduced that power by 1 to get 2x squared, plus x plus 3, plus 3 divided by the 2 times x minus 1/2. or 2x minus 1. So our final answer is 2x squared plus x plus 3 plus the remainder 3 we divided both by 2 and the x minus 1/2 factor, which is 3 times divided by 2x minus 1. For the given polynomial p of x and the given value of c, we're going to use a remainder theorem to find p of c. Now the synthetic division gives us another way to evaluate polynomials. What you could do in solving these without using synthetic division is to evaluate p of 2 by plugging 2 into each of those x values. And you would get 2 to the third minus 2 times 2 to the second plus 3 times 2 plus 8. Now you can work that out, or you could use synthetic division. This is how we set this up. The number that we're putting in the box is the value that we're evaluating. C equals 2. We're going to put a 2 in the box, and then we use the coefficients 1, -2, 3, and 8. This is our setup. As always, we bring down that first coefficient, 1, and whatever's below the line we're going to multiply by what's in the box. 1 times 2 is 2. Add those together. -2 plus 2 is 0. 0 times 2 is 0. Add 3 plus 0 is 3. We multiply. 3 times 2 is 6. And then 8 plus 6 is 14. Now whatever number that would be the remainder if we were dividing by polynomials is the same thing as the value you get by plugging in the given value into the original polynomial. And if you work that out, you would see that you would get the same result. So synthetic division gives us another way to evaluate polynomials. In part B, we have the polynomial x to the third plus 4x squared minus 3x. We're going to set this up using synthetic division. Minus 3x minus 5. The value of c is -2, so we're going to put a -2 in the box using the coefficients 1, 4, -3, and -5. We are going to always bring down that first coefficient, 1. 1 times -2 is -2. Add those together. 4 and -2 is a positive 2. 2 times -2 is -4. Add those together to get -7. -7 times 2 is 14. And we add those together to get 9. So that answer, that remainder value, is the same thing as if you were to plug 2 into that original polynomial, -2 into that original polynomial. You get -2 to the third plus 4 times -2 squared minus 3 times -2 minus 5. That is going to equal 9. Let's use synthetic division to evaluate p of x, the polynomial 8x to the fourth minus 4x to the third plus 2x squared minus 11x minus 6, where c is equal to 1/2. We use synthetic division here by putting 1/2 in the box, and the coefficients 8, -4, 2, -11, and -6. We bring down that first term, first coefficient, 8, multiplied by the number in the box. 8 times 1/2 is 4. We add those together to get 0. 0 times 1/2 is 0. We add those together to get 2. 2 times 1/2 is 1. Add those together to get -10. -10 times 1/2 is -5. Add those together to get -11. So -11 is the answer if we were to evaluate this polynomial when x is equal to 1/2. You could check this by plugging in 1/2 into all of those x values. So 8 times 1/2 to the fourth power minus 4 times 1/2 to the third power plus 2 times 1/2 squared minus 11 times 1/2 minus 6. If you were to evaluate that, you would get the same answer as the remainder that we did with synthetic division. For example D, the polynomial is 3x to the fourth minus 7x plus 6, or C is equal to 3. In order to use synthetic division to evaluate this, we want to make sure we have the right space fillers here. 3x to the fourth is the first term, but notice there's no x cubed term, so I'm going to put a 0x to the third. There's no x squared term, and then we have minus 7x and plus 6. So we can use these coefficients for our setup with synthetic division: 3, 0, 0, negative 7, and positive 6. And since the c is equal to 3, we're going to put a 3 in the box. So always we bring down that first coefficient of 3, multiply 3 times 3 to get 9, add 0 plus 9 to get 9, multiply 9 times 3 to get 27, add 0 plus 27 to get 27, multiply 27 times 3 to get 81, add negative 7 plus 81 to get 74, multiply 74 times 3 to get 222, and then add to get 228. So if you are evaluating that polynomial where c is equal to 3, so p of 3, if you were to substitute 3 times 3 to the fourth minus 7 times 3 plus 6, that answer will equal 228.